Welcome to this session where we are going to talk about the architecture and the functioning of ChatGPT. In the previous session, we've learned that ChatGPT is a large language model that's been developed by OpenAI, and it's based on the GPT 3.5 architecture. This architecture of ChatGPT can be understood as a combination of several components that work together to enable it to understand natural language and generate coherent and meaningful responses. The architecture of ChatGPT can be broadly classified into two components. The encoder, which is the first part of the architecture. This part takes the input text and converts it into a sequence of vectors that can be processed by the decoder. The input text is first tokenized, which means it is split into individual words or subwords, and each token is assigned a unique integer ID. This ID is then fed into an embedding layer which maps each token ID to something known as a dense vector. This embedding layer is a learned lookup table that tries to preserve the semantic meaning of each token in the vector space. Once the token IDs are mapped to the vectors, they are passed through a series of transformer layers as we discussed in the previous session. The transformer layer consists of several self-attention mechanisms followed by a feed-forward neural network. The self-attention mechanism allows the model to weigh the importance of each token based on its relevance to the other tokens. This helps the model understand the context of input text and capture long-range dependencies. The feed-forward neural network applies nonlinear transformation to the input vector, allowing the model to capture more complex patterns in the data. The other part of the architecture of ChatGPT is the decoder. The decoder is the second part of the architecture that takes the sequences of vectors that are generated by the encoder and uses that to generate the output text. The output text is generated one token at a time, and at each step, the model predicts the probability distribution over all possible tokens given the input sequence so far. The token with the highest probability is then selected as the output token for that step. This process is repeated until the model generates an end of sentence token or reaches a maximum output length. Decoder also consists of a series of transformer layers similar to the encoder. However, in addition to the self-attention mechanism and feed-forward neural network, the decoder also has an additional cross-attention mechanism. This mechanism allows the decoder to attend to the encoder's output and selectively focus on the parts of the input that are most relevant to the current output token being generated. This thus helps the model to generate a more coherently and more contextually appropriate response. Overall, the architecture of ChatGPT is designed to enable it to understand natural language and generate a meaningful response. The combination of this encoder and decoder, along with the self-attention and cross-attention mechanism, allows the model to capture the context of the input text and generate responses that are relevant and appropriate to the conversation. This makes ChatGPT a powerful tool for tasks such as language translation, text summarization, and conversational AI. So, let's summarize the workings of ChatGPT. The workings of ChatGPT are mainly divided into three components. The input processing, the first step of ChatGPT. The model takes the natural language as an input, pre-processes it to get relevant information, tokenizes it, converts it into sequences of numbers that represent the meaning of the text. The process involves several steps, including sentence segmentation, tokenization, and subword encoding. Sentence segmentation involves breaking down the text into individual sentences, making it easier for the model to understand the context. Tokenization involves breaking down each sentence into words, which are then assigned numeric numbers. Subword encoding is used to further reduce the vocabulary size by breaking the words down into smaller subunits that occur frequently in data. The next step is basically the neural network architecture. Once the input has been pre-processed, it is passed through the neural network architecture of ChatGPT. The model is composed of several layers of artificial neurons that are designed to process sequential data. The architecture of ChatGPT is based on a transformer model, as we discussed in the previous session. This was first introduced in a paper known as Attention is All You Need by Vaswani in 2017. The transformer model is a type of neural network architecture that uses the self-attention mechanisms to process sequential data. Self-attention allows the model to focus on different parts of the input sequence and extract the information it needs. The transformer model also consists of the encoder and decoder. The encoder, as we discussed, takes the input, processes it, passes it through the layer of self-attention and feed-forward networks, and thus generates an output by using the decoder, which basically decodes the hidden representation from the encoder and generates an output. Lastly, in the output, the final step in the working of ChatGPT is the output generation. Once the input has been processed by the neural network architecture, the model generates a response to the input query. The response is generated by sampling the output distribution of the decoder, which is a probability distribution over the subword vocabulary. ChatGPT also incorporates several techniques to improve the quality of the generated responses. These techniques involve fine-tuning the model on specific tasks, using ensembled models to generate more diverse responses, and incorporating user feedbacks to improve the model's performance. In conclusion, ChatGPT is a powerful language model that uses deep learning techniques to generate human-like responses to natural language queries. Its workings involve input processing, neural network architecture, and output generation, which all work together to generate meaningful and relevant responses. The model's ability to learn from large amount of text data and generate diverse responses make it well suited for a wide variety of natural language processing tasks. Thank you.